let's practice finding molar mass of some compounds. So you want a periodic table, because we're going to need to look up the molar masses of each individual element, and you might want a calculator. Here is an example of finding the molar mass of hydrogen peroxide. And now, again, like they're showing this with all these fancy proportions, which is fine. But in the end, I just want to see what you plugged in your calculator. And so, for example, I usually do it like this. H2O2. Well, there's 2 atoms of hydrogen. But if I'm looking for the molar mass, there'd be 2 moles of hydrogen. So maybe I'd say like hydrogen. There's 2 moles, and the molar mass of hydrogen is really about 1 gram per mole. Then I go to my next element, oxygen. There are 2 moles. And I look on my periodic table, and the molar mass really is about 16 grams per mole. I'm okay if you want to show your work like that. I mean, you're still going to get the same answer. If I can estimate here a little bit, yeah, 16 times 2 is 32. 32 plus 2. Yeah, that's 34 grams per mole. That's the molar mass of H2O2. 1 mole, 6.02 times 10 to the 23rd H2O2 molecules. So, however you want to show your work is fine for me, as long as you can show me what you're plugging in your calculator. So you can do this, or you can just do something like that. I'm totally fine either way. All right, let's try a few. Phosphorus trichloride. So I'd probably say phosphorus, there's 1 mole. Oh, phosphorus, oh brother. So different periodic tables are going to have different numbers of figures. There is a periodic table in the back of your book, which is probably the one that you're going to use most often. It's on the way back cover. And I like this periodic table because the masses aren't super crazy. Now, I have noticed that throughout some of these other sample questions, they've been like rounding the masses to a whole number maybe. I don't mind if you leave all the decimals. And in fact, I'd almost prefer it. Eventually, we can round after we do some calculations, but what's the harm in saying 30.974 grams? So the 1 is like saying it's 1 mole, and every mole is 30.974 grams. Next comes chlorine. There are 3 chlorine, or 3 moles of chlorine. And then I look up the mass to be about 35.45 grams. And then boom, add them together. And again, if you were looking at a different periodic table, it might show a little bit different mass, but in the end, they're all pretty similar. All right, so let's add these up. 4, and I'm looking at about 137.324 grams per mole. And that's for the PCl3. Hopefully you're in the ballpark. Gosh, this is so easy, right? I mean, I think initially they try to make it into something that's going to be really wacky, and when you break it down, it's super simple. And it's something that we're going to do a lot of, and eventually I'll say you don't even have to show work. Just plug it in your calculator. I mean, now when we're trying to learn the concept, then we show what we're plugging in our calculator. What if I want to know the mass of 1 mole of sodium hydrogen carbonate, also known as sodium bicarbonate baking soda? I'd say, all right, I got a sodium. There's 1 mole of sodium in a mole of sodium hydrogen carbonate molecules. And then I look up the mass on my periodic table, 22.99. And I got some hydrogen. There's only 1 mole, and its mass on the periodic table is 1.008. Next, I have a carbon. There's 1 mole of carbon, and its mass is 12.011. And finally, the oxygen. There are 3 oxygen times its mass, 15.999 grams. And then you just add them all up. Plug it in your calculator. And I'm looking at about 84.006 grams per mole of sodium hydrogen carbonate molecules. So if I went in the lab and I measured about 84 grams of baking soda, which is a reasonable number, I could measure 84 grams. An 84-gram sample of baking soda, sodium hydrogen carbonate, is equivalent to a mole, which would be equivalent to 6.02 times 10 to the 23rd molecules.